Okay, let's go ahead and try another problem. This is very similar to one that's in your lab manual as well. Now, this one says, you discovered a population of 450 lady beetles. Some of them had spots and some of them didn't. And you know that the spots are dominant to no spots, right? So you decided to count the beetles with no spots because, again, you know the genotype of that. If it was a lady beetle with spots, since that's dominant, you do not know the genotype. Remember, there are two possibilities for the dominant, right? Well, dominant. Okay, it could be a homozygous dominant individual or a heterozygote. Okay, those with no spots that you know it's recessive, you know the genotype is this. So you always want to kind of start with this if you're only given phenotypes or genotypes where you're only given the number of individuals that have the recessive trait. Now, so here you're going to determine what the allele frequencies and the genotype frequencies are. Now, what we're going to do is looking at this problem. This is kind of where I would start. I know the total population is 450 beetles, and I know how many of them have no spots. Okay, so no spots. I know that those with no spots are homozygous recessive. Okay, so I know that there are 75 out of 450 of them that have no spots. So that is going to equal, after calculating that comes out to 0.616666. So we're going to round up to 3 decimal places, and you should probably do that in the lab as well. Now, little b, remember, is going to be the same as q squared. So we know q squared is 0.167, right? So what would you want to do next? I can't find p squared or the homozygous dominant because I don't really know what's what here. So all the dominants could be this. So I'm thinking q squared. I can find q, right? So if I take the square root of q squared, okay, or the square root of 0.167, okay, I should come up with 0.408. Okay, so now I know Q, right? So this is Q equals 0.408. Now I can find P because remember P plus Q equals 1, right? So here we have P plus 0.408 equals 1. So P equals 0.592. Okay, so now I have Q and I have P. Okay, those are their allele frequencies. Now we're going to finish up the genotype frequencies now that we have the allele frequencies. So we're going to go back. Okay, so we know that we have little b, which is actually the same as q squared. Right. So now we want to find p squared, and we want to find 2pq. So p squared is the same as the homozygous dominant, and 2pq is the same as the heterozygotes, right? So let's go ahead and do that. So for the homozygous dominant, we want to go ahead and use p, right? Because we're going to take p and multiply it by p. So that's the same as doing this. Okay, so 0.592 squared equals 0.35. So we know the frequency of p squared, okay, which is the same as the homozygous dominant. Now we want to find the heterozygotes, right? So we have the heterozygotes. We have 2 times 0.35 times 0.167, right, equals 0.483. So you can see I'm carrying 3 decimal places, and that might not come out even when you add up to 1 and you're checking your problems in the lab manual. But if you carry up to 3 decimal places, it should work out nicely for you, right? So we know this equals 1 because we use this calculation to actually do it, right? So we know P plus Q equals 1. Now we want to check the genotypes. Okay, so 0.167 plus 0.35 plus 0.483 totals to 1. Okay, now that we know the allele frequencies and the genotype frequencies, there's another question here. It says, determine how many of the lady beetles are heterozygous. So what do we want to do? We know the total population is 450. Okay, we know there are 450 beetles. Okay, we want to find out how many of them are actually heterozygous. Conveniently, we know the frequency of the heterozygotes, right? So we know the frequency of the heterozygotes is 0.483. So then think about what you want to do with that. So thinking about it, the frequency, remember, represents the proportion of individuals with that particular trait. In this case, we're talking about the heterozygotes. Okay, so that's the part of the entire population. So what you want to do is multiply the total population by that fraction, 0.483. Okay. Now you want to multiply it. So this is like multiplying here. And we should come up with a number like 217.35. Oops, 5.